All right. Good morning, good afternoon, good evening, whatever part of the day you're in. All right. So we're gonna practice. This is really the beginning of some good chemistry. So now what we're doing is we're gonna be translating this from the language of English into the language of chemistry. And so this is a beautiful thing to me because it's written out in English, and as chemists, we can convert this into our language. So let's go ahead. Let's get started. All right, so this one is asking me to write a balanced equation for a synthesis reaction between aluminum and fluorine. Okay, this should be pretty easy. So the first thing I want to think about is I want to think back to my notes and think about the equation for a synthesis reaction. So let me check in my notes. Okay, here it is. So in my notes, it tells me that for a synthesis reaction, we have A plus B. And then that's going to yield some new chemical compound, AB. Okay, so that's pretty easy. So I'm starting off with the formula for a synthesis reaction. And now I want to get into the meat of it. And let's talk about aluminum and fluorine in this reaction. So, so this one, we're writing the balanced equation for a synthesis reaction between aluminum and fluorine. So this is going to be on the reactant side. So I know ahead of time that I'm going to be dealing with my left side of my equation. This is going to be on the reactant side. So I'm starting on the reactant side. So let's start on the reactant side. The first thing we have is we have aluminum. And then we also have chlorine. All right, so now we have aluminum and chlorine, but this is a special guy. I remember this guy, he's a non-metal, and I know that non-metals, some of those like to kind of pair up. They don't want to be by themselves. So I'm going to think back to my diatomic elements. So the diatomics are going to be non-metals. It's going to be this upside down L. I remember that one. My NOF, and then fluorine, chlorine, bromine, iodine. So upside down L here. And then there's one tricky guy. He's a non-metal, although he has some properties that are characteristic of metals. So he is a diatomic, and then nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So we have H, and then I have my up, down, NOF, L. All right, so since he's a diatomic, he's very unstable, so he gets 2 there. Okay, cool. And then for a synthesis reaction, all we're doing is we're combining those 2 things together. All right, so this is going to be a metal and a non-metal coming together. Oh, this is an ionic compound. The first thing I need to do for ionic compounds is I need to look at their charges. So I don't want to skip that step. I could get in big trouble if I skip that step. So let's take a look at their charges. And then chlorine is a 1 minus. Okay, so these have a different charge, so I know I'm going to have to do a cross and drop. So that means my aluminum gets a 1, so this is Al. I'm just going to leave off the 1. It's understood that it's a 1. All right, and then here, this is chlorine. Bam. All right, so now we have aluminum chloride, and then this was the reactant. So we have our reactants, we have our product. Here is our yield sign. We have the correct elements. We notice that this is a diatomic, and we have the correct formula for this ionic compound, aluminum chloride. All right, and then they asked us to make sure it's balanced. So we also have to balance it. So I know that the first step in balancing the chemical equation is I need to go ahead and split up my reactants and products. So now I have my reactant side. I also have my product side. And then we're going to make a list. So let's make a list of all of my reactants. It's going to be the same on the product side. Matter is neither created nor destroyed. So we need to have the same thing on the left side, same thing on the right side. Products and reactants need to be the same. Aluminum chlorine, aluminum and chlorine. All right, no problem. All right, so let's get started. So we have 1 aluminum on this side. On this side, we also have 1 aluminum. Okay, those are balanced, no problem. All right, over here we have 2 chlorines. Over here we have, oh, this is 3 chlorines. These are not balanced, so I need to balance those. To balance them, I'm going to use the least common multiple. So let's look at the least common multiple, 3, 2. Multiples of 3 are 3, 6, 9, 12, 15. Multiples of 2 are 2, 4, 6, 8, 10. All right, so I see that we have least common multiple is going to be 6. This is our smallest one. There's no multiple that they have in common that is lower than 6. So this is our least common multiple. We don't have any other multiples. So, all right, let's see what we need to do. All right, so to get 6 on this side, I'm going to use a coefficient of 3. So this will be my coefficient here. And remember, when balancing, we never touch a subscript. We only balance with coefficients. All right, so now we have 6 over here. Here we have 3. Okay, what do I need to multiply by? Coefficient of 2. So coefficient of 2 gives me 6 on this side. So and there we go. And then the most important step of all, because I know Mr. Cantor is always trying to trick me. This guy must have a vendetta out against me or something, but I know that he's vigilant. He's going to track these people that skip steps. He's going to track them down one by one and give them tutorial. So I know that he's probably designed this problem such that if I don't go back and check to make sure something's unbalanced, I'm probably going to get, I'm going to run into some problems. So I'm not going to skip that step. The last step is always to go back and make sure nothing became unbalanced, especially for Cantor problems, because he makes his own problems. He knows that I like to skip steps, so he's made these problems so that he can catch me skipping steps. I'm not going to do it. I'm going to save some time. I'm going to go back and make sure nothing became unbalanced. All right, so we got 1 aluminum. Okay, that's fine. Still the same thing. 2 aluminums. Wait a minute. Okay, so I got to take this off now because Mr. Cantor was right. I'm glad I went back and checked this to make sure nothing became unbalanced. Okay, so we have 1 aluminum, 2 aluminums. Okay, least common multiple of 2 and 1. That's going to be 2. So multiples of 2 are 2, 4, 6, 8, 10. Multiples of 1 are 1, 2, 3, 4, 5. The lowest multiple for this one is going to be 2. We already have 2 on this side, so I need to multiply by 2 to get a 2 on this side. Okay, so this is going to be a coefficient of 2. Okay, so now they're balanced. Okay, so let's check it and see. I still have to make sure that when I go through this, everything should be balanced. If not, I need to balance it some more. 2 aluminums. Okay, 2 aluminums. Okay, we're fine. 6 chlorines. Okay, we're fine. 6 chlorines. Okay, we're fine. All right, so this one is done. This is our final answer here. Good job. All right, and then let's take a look at the next one. All right, let's continue. All right, so for our next one, this one says write a balanced chemical equation for a single replacement reaction that produces boron and potassium sulfide. I also find it interesting that kids think they started the shorthand. It was actually chemists. The first one to use this type of shorthand was chemists, not social media persons. So chemists. All right, so this is an interesting equation. So single replacement. All right, hold on. Let me check my notes because I'm going to start with the equation for a single replacement. All right, I got my notes right here. Cool. So I've gone back and looked at my Mr. Cantor notes in Schoology, and now I have the equation for a single replacement reaction. It says that it's going to be A plus BC, and that's going to yield B plus AC. All right, so we have some compound, and we have a metal. We're going to replace the metals, and then we have a new compound. then the other metal got kicked out. This usually will appear as a precipitate. So we'll see something solid that comes out of solution. All right. So write a balanced chemical equation for a single replacement reaction that produces boron and potassium sulfide. Okay, so now, first thing I'm noticing is that, well, Mr. Cantor didn't give me any reactants. So I don't see any reactants on here, but I do see the products. So I'm going to start with the product side first this time. Seems a little strange, but I'm going to start with the product side first because that's all we have is the product. But I want to make sure that I'm on the right side. So it produces this. Okay, so these aren't reactants. So I'm not going to start on the left side this time. I'm starting over here on the product side. Okay, got it. All right, so the first thing we have is boron. That's a metal. He can exist by himself. And then the next thing we have is potassium sulfide. All right, let me write the charges. I'm not going to skip any steps. All right, these are a different charge. So I'm going to cross and drop. So this is K2S. All right, so we have the products. Now we need the reactants. Okay, so I'm just going to work backwards. So if we started with A and BC, we got B and AC. So now let's just start with B and AC, and then I guess what's going to happen is we're going to see that now, okay, the B comes in. So he was here originally, and then the A was originally out. And then so we're going to push this one back out. So that potassium is coming out of there. All right, so that potassium is coming out. And then, hey, y'all living too loud back there, ladies, sitting right next to each other. All right, so for this one we have potassium. Potassium came out. And then now we have boron. This is another compound, so I need to look at the charges. This is a 3 plus. Sulfur is a 2 minus. So this is going to be a cross and drop. So we have B2, S3. All right, so now we have the equation. Check this out. That anymore. All right, and then on this one, let's go ahead and let's start balancing. So I know the first step is, it's not a matter of science, it's a matter of effort. So my first step is always here. So now I have my reactant side, I have my product side. Next thing is I need to make a list. I need to make a list of all the chemicals that are present. So we have no oxygen or hydrogen, so I can just list what I see, KBS, and oxygen and hydrogen always come last. All right, so on this one, we have 1 potassium, 2 potassiums. So over here we have 1, over here we have 2, and then we need to do the least common multiple of 2 and 1. All right, and then I can see that the least common multiple is 2. There are other multiples, but the lowest one is 2. We already have 2 on this side. To get a 2 over here, we need to multiply. So now we've multiplied by 2. These are balanced. Next one is B. So we have 2 B's on this side, 1 B on that side. Least common multiple of 2 and 1 is 2. I already have 2 on this side. I need to multiply by 2 on that side. Over here we have 3 sulfurs. Over here we have 1 sulfur. The least common multiple of 3 and 1 is 3. So we have a 3 on this side. I need to multiply by a 3 on that side. And then I already know that Mr. Cantor is going to try and track those people that are skipping steps. He's going to track them down one by one. So I already know that Mr. Cantor set this equation up so that if I don't go back and check it, I'm going to run into some trouble. So I'm just going to go back and check it because I know how he makes his problems. All right, so now we have 2 potassiums, 6 potassiums. You know, I knew that. I knew it because Mr. Cantor, he always does this. He always does this. So over here, now we have 6 potassiums. And so instead of a multiplier of 2, we're going to have to change that multiplier. We're going to change that one to a 6. And then now we have 6 potassiums, 6 potassiums. I'm glad I went and checked that one. All right, and then for the next one, we have 2 borons, and then we have 2 borons. So these ones are already balanced. And then here we have 3 sulfurs, 3 sulfurs. All right, so everything should be balanced. 6 potassium, 6 potassiums, 2 borons, 3 sulfurs. So this one is balanced. But I always want to make sure I go back and I check because sometimes, well, not sometimes, the majority of the time, Mr. Cantor is going to make a problem that requires me to go back and do that last step just to make sure I get in the habit of it. All right, so this is, we're translating from the language of English, and now we've translated this into the language of chemistry. So that's a beautiful thing. All right, we'll see you on the next video.